So today's topic is Heisenberg uncertainty principle, which is equal to delta x dot delta p is equal to h cross, or delta delta t is equal to h cross or h. Okay, so h cross is the h upon 2 pi. So in the so we will see this how this equation is comes, that is Heisenberg uncertainty principle, that we will see. So in the properties of the matter wave, the position of the particle becomes uncertain when it is described as a wave group. Okay. So in the yesterday we have described the all the particles that are moving with velocity. So these are the velocity of the particle when they are moving. So we are describe it as a wave packet. So there are number of waves which are moving along with the particle. There is no single wave that is associated with the particle. This was our yesterday's discussion. So this is the particle, this is the particle, and this is the particle. So wave is associated with each particle. This was by de Broglie hypothesis, that particle is all the matter particles such as proton, electron, neutron are moving, and they have associated with them is the wave. Okay, but there is no any single wave, but group of wave are associated with the particle. So this is the group or wave group we have described yesterday, that is associated with the particle. Okay, so the position of the particle become uncertain when it is described as a wave group. So you can't find the particle in this wave group. Okay, so it may be present here, it may be present here, it may be present anywhere in this wave group. So you can't say that this particle is present here or here. So this is the uncertainty principle. This is called as the Heisenberg uncertainty principle, that we can't able to say where the particle is located in the wave group. Okay, when the particle and waves are moving in the space. So this is the uncertainty principle. So the particle may be located anywhere within the wave group, but its exact location within the wave group is not known. So this is the, you can't able to find a particle where it is located in this wave group. So this is the wave group or wave packet. Yesterday we derived this definition of what is wave group or wave packet. So I want to take this first. So what is phase velocity? The rate at which the phase of the wave propagates in the space. So this is the wave that is propagating in the space is called as the phase velocity. So whatever velocity of this wave is called as the phase velocity. And what is the group velocity? The rate at which envelope of the wave packet propagates. So this is the envelope of all the wave packet. How this is formed? This is formed by the superposition of the two or more wave. Okay. So when two or more waves superimpose, then wave packet is formed. Where is the maximum you will get and where is the minimum you will get? How you can able to find this? By the superposition principle, where the crest of the one wave, so this is the one crest, when super with the another wave of the crest of the another wave, there you will get the maximum amplitude. तो यहाँ पे मुझे maximum amplitude मिलता है. And where we are getting less amplitude or zero amplitude, when the crest of the one wave, this is the crest of the one wave superimposed with the trough of the another wave. So this is the trough, where this is the that is the crest is superimposing. Okay, so when the crest of the one wave superimposing with the trough, at that point we are getting the less or zero amplitude of the wave. Okay, so this is the wave packet that we are getting. So where we are getting maximum and minimum, it depends on the how these two waves are superimposed with each other. So ये किस पे depend रहता है? This maxima and minima, it depends on the how these two or more are superimposed with each other. Okay, crest of the crest and trough with the trough, or crest and trough. It depends on that. So this is the nature of the wave packet. This is called as the group velocity. Okay, उसे हमने क्या बोला है? Group velocity. The rate at which the envelope of all the wave packet propagate in the space is called as the group velocity. So yesterday we had derived this equation. This is the equation for the phase velocity, which is equal to uh, angular frequency divided by propagation constant k. Okay, or k is also called as the wave vector. उसे wave vector भी बोलते हैं. So this is the equation for the phase velocity. And for the group velocity, what is the equation? Vg is equal to d omega upon dk. Okay, where omega is the wave angular frequency and k is the wave number or propagation constant. So the particle may be located anywhere in the wave group, but its exact location within the wave group is not known. So we can't able to say where it is particle is located. So this is the uncertainty principle. Narrower the wave group, smaller is the uncertainty in its position. Narrow the wave group means this is. It means its length of this wave packet is very small. Okay, narrow the wave group, more exactly, more will be the possibility or less is the uncertainty. Okay, narrower the wave group, smaller is the uncertainty in its position. It means you can able to find this particle anywhere in this small length. Okay, but if this length is very large, okay, this delta x is very large, then it is not possible for you to find a particle where it may be located here or anywhere else. Okay, so this is the difference between this figure, that is a small wavelength and large wavelength. So narrower the wave group, smaller is the uncertainty in its position. So smaller will be the uncertainty in its position if this wave group is narrow or very small. Okay. In purely sinusoidal wave, psi of x, the Fourier transform g of omega gives amplitude only at a single frequency as shown in figure below. So this is the sinusoidal wave we have. Sinusoidal means it has equal amplitude. Okay, all this wave, this is one wave, this is from this point another wave is started. So all these wave are having equal amplitude. Amplitude सबका क्या है? Same है. So that's why we call it as a sinusoidal wave. So it has this peak is here, that is this length. So it is showing the, so this sinusoidal wave psi of x gives the Fourier transform g of omega, gives the amplitude only at a single frequency. So this is the amplitude that we are getting here, which is of the single frequency. Okay. For a wave group of broader range of frequencies are present as shown in figure, and for the wave group of broader range means, so in this figure here you will find that this is the broader range of the wave. The amplitude is changing here. Okay, this is the maximum, then this is less than that of previous one. You will see that it is decreasing. So amplitude of the wave is decreasing here. So we call it as a broader. For a wave group of broader range of frequencies are present as shown in figure. So the frequency of this kind of wave is like this. तो उसकी frequency कैसी है? Like this. It will get change from single frequency to this is broader frequency. Okay, and for single amplitude and for the narrow pulse, this is the narrow pulse we have. For the narrower pulse, we have such a kind of frequency. This is the frequency. This is the output. All these are the output. These are the input. Okay. A very large number of frequencies are present. तो Fourier transform, what is Fourier transform? Fourier transform क्या होता है? The Fourier transform is an important image processing tool which is used to decompose an image. Okay, so it is image processing tool. This is mathematical representation of the wave. Okay, or it is a tool. Is an important image processing tool which is used to decompose an image into its sine and cosine components. Okay, so it is converted into sine and cosine components of all the images or the waves. The output of the transformation represent the image in the Fourier or frequency domain. So this is the output that we have. It is the output of the transformation represent the image in the Fourier or frequency domain, while the input image is the spatial domain equivalent. So this is the definition of the Fourier transform. Hence, if the wave group is narrower, it will be consist of large number of frequency. So if this wave group is very narrow, then what happens? Frequency will be much more. So narrow the hence narrow the wave group is the, hence if the wave group is narrower, it will consist of large number of frequency. तो उसमें क्या है, frequency ज़्यादा रहती है, and hence wavelength, due to which the wavelength becomes more uncertain. So the relation for the wavelength भी क्या होती है, uncertain हो जाती है. Okay, if the wave group is narrower, then it will consist of large number of frequencies, and hence wavelength is also due to which the wavelength becomes more uncertain. So उसकी वजह से क्या है, wavelength भी uncertain हो जाती है. Okay, so we have a relation, de Broglie relation, lambda is equal to h upon p, which is nothing but the momentum. So wavelength is equal to what? Planck's constant divided by momentum. T is the momentum, h is the Planck constant. So we have derived this equation, that is in the de Broglie hypothesis. What is P here? P is mass of the particle and V is the velocity. Mass of the particle multiplied by velocity of that particle. So lambda is equal to h upon mv. Okay. So you can say that as uncertainty in the wavelength, अगर wavelength भी uncertain है तो क्या हो जाएगा? Your momentum will get uncertain. Okay. As an uncertainty in the wavelength leads to the uncertainty in the momentum. So momentum भी uncertain हो जाएगा by this relation. Okay. From above discussion, we can conclude that for narrow wave group, there is a small uncertainty in its position. So in this figure, for the narrow wave group, this is the narrow wave group we have, there is smaller uncertainty in its position. So delta x is the position. Okay, so delta is the position where particle may be located. It may be located here. So this is the delta x is the length of this wave group. So smaller is the uncertainty in its position. Okay. From above discussion, we can conclude that for narrow wave group, there is a small uncertainty on its position, but large uncertainty in its momentum. Okay. So that's why large uncertainty on its momentum. Momentum means momentum. So the momentum is equal to what? Lambda. Momentum is equal to mass into velocity. Okay, mass of the particle and with which it is moving from one place to another. So momentum क्या हो जाता है, large हो जाता है. If the uncertainty position is small, then momentum becomes large. Okay. So this is the relation between the position and momentum between the uh, of the moving particle in the wave group. Okay. And उसका reverse case यहाँ पे है. अगर it is if the position will be very uncertainty in the position is large, then uncertainty on its momentum becomes small. तो यहाँ पे uncertainty on its momentum becomes small here. So this is the reverse case when this delta x becomes large. Delta x means position of the particle on this wave becomes large, then on its momentum becomes small. तो momentum क्या हो जाता है, small हो जाता है, यहाँ पे large हो जाता है. Okay. So this was the discussion. This was our final conclusion, that from our discussion we can conclude that for narrow wave group there is a small uncertainty on its position but large uncertainty on its momentum, whereas for the broader wave group there is a large uncertainty in its position and smaller uncertainty in its momentum. Okay. So this was our conclusion of all the discussion. Why this position related with the momentum? Because of the wavelength. And wavelength is equal to what? H upon P. Okay. So that's why P is comes into picture in this formula. So this was uncertainty relation. The Heisenberg uncertainty principle states that it is impossible to determine both the exact position and exact momentum of the particle at the same time. तो Heisenberg ने क्या relation बताया? So it was very difficult for us to find the exact position of the particle. So where is this particle on this wave? It is very uncertain for us to decide exact its position. Similarly, we can't able to find the exact momentum. Okay, momentum means mass into velocity with which the particle is moving. So this was the relation, that is delta x dot delta p is greater than h. H is the Planck's constant, or h cross upon 2 pi. Okay. So the product of uncertainty is always greater than or equal to the Planck's constant. So this was the relation stated by the Heisenberg uncertainty principle. Now we will see uncertainty in terms of energy and time. Okay. Now we will see uncertainty in terms of energy and time. यहाँ तक समझ में आ रहा है सबको? Hello?
Yes, sir.
Okay. Now we had seen the uncertainty in terms of position of the particle and momentum of the particle. Okay. Now we will see what is uncertainty in terms of energy and time. Just wait for 1 minute.
Okay, sir.
Now we will see what is uncertainty in terms of energy and time. We know the equation for the kinetic energy of the particle. So E is equal to 1 half m square, where m is the mass of the particle, v is the velocity of the particle. So the kinetic energy acquired by the particle is 1 half m square. Okay. So we have studied this in classical physics also. ये आपने study किया है. Mechanics में भी आपने देखा होगा, E is equal to 1 half m square. So this is the energy with which electron is moving, or a proton or neutron is moving. So the uncertainty in the energy is obtained by differentiating above equation. So differentiate this equation, then the equation I am getting that after differentiating T comes to be delta E is equal to 1 half m into differentiate with respect to V, okay? Because mass of the particle is constant, this 1 half is constant, so variable is the velocity. So variable क्या है? Velocity. So that's why we are differentiating with respect to V. तो इसलिए हमने क्या किया है? Differentiate किया है with respect to the V. तो उसका डेरिवेटिव क्या आ जाएगा? 2 times V into dV, ओके? 2 times V into dV, ये आपने मैथमेटिक्स में पढ़ा हो. Derivative of something raised to square is equal to 2 times of this one, 2 times V into dV, okay? Now common term will get cancelled out here. 2 will get cancelled out. Then the what equation I will get?
G. Huh?
Hello? What happened? So what equation I will get? 2 will get cancelled out. V, I had taken this V out of the bracket. Then in the bracket I am getting m into delta V. Okay. So delta E is equal to what? V into m into delta V. So this is the equation I got here. And we know that momentum is what? Momentum is equal to mass of the particle and velocity of the particle. Okay. So momentum means what? Mass of the particle multiplied by velocity of the particle. So I had taken the differentiation of this also. Then I am getting this equation. Delta P is equal to m into delta V. Mass is constant. So variable is what? Your velocity. So velocity is variable. So your momentum will also become variable. Okay. So delta P is equal to m into delta V. So instead of this m delta V in above equation m delta V, you can put here delta P. Okay. So delta E equal to what? V into delta P. So delta E is equal to V into delta P. So I had just used this equation. So instead of this equation m into delta V, I had put a delta P here by this relation. That is momentum is equal to mass into velocity. So now I have taken this delta P on the denominator here. So the what equation I will get? But we know that what is V? Velocity is equal to kya hai? Rate of change of position. So delta x is the change in its position with time. So within the how much time? What is the position? So it is nothing but the velocity. So I have put this here. Velocity equation, that is rate of change of position divided by rate of change of time. So delta is equal to what? Delta E, delta x upon delta t into delta p. Okay. ये equation मैंने यहाँ पे put किया. Okay. So velocity क्या रहती है? Rate of change of position with time. ये आपने पढ़ा होगा. So I had just used that equation here. So I got this. So I had taken this delta t on this left hand side, then I am getting this equation. Okay, so both the equation are equal. Okay, so that's why Heisenberg uncertainty principle is equal to, earlier we had proved as this one, delta x dot delta p is equal to h cross. So we can now note down that delta e dot delta t also is equal to h cross. Okay, so this was the uncertainty principle. Delta E dot delta T, which is greater than equal to h upon 4 pi, or you can write down h cross upon 2 pi. Okay. H cross means what? H upon 2 pi. So h upon 4 pi, that will be, this value is greater than h upon 4 pi, or this delta x dot delta P greater than equal to h upon 4 pi. Or you can write simply h here also, that will be also acceptable. So here what is delta E is the uncertainty in its energy, delta T is uncertainty in its time, and h is the Planck's constant. Delta x is what? Uncertainty on its position, delta P is uncertainty on its momentum, and H is the Planck's constant in this relation. So we got these two equation, delta E dot delta T greater than H and delta X dot delta P greater than H. Okay, so this is called as the Heisenberg uncertainty principle. Heisenberg uncertainty principle is relatively simple to understand due to the energy that must be applied to the system to be observed. Certain pair of variables such as energy and time, position and momentum cannot be observed simultaneously. So we can't find the position and momentum of the particle exactly at the same time. Similarly, you can't able to find the energy and time of the particle at the same time. So this was the uncertainty that is derived by the Heisenberg while considering the motion of the particle in the wave packet. Okay, so you cannot be observed simultaneously and still both the are measured precisely. So for instance, position and momentum of a quantum particle cannot both be measured because of the high frequency photon. So you can't measure this position and momentum. Position means delta x and momentum means delta p at the same time. So in the quantum physics, you can't able to measure both at the same time. Both be measured because of high frequency photon. Okay. So because of high frequency photon, you can't able to measure this at the same time. High frequency photon used to measure the position precisely would give you poor momentum value and vice versa. How we are measuring this position of the particle? By the, because we are measuring the light only. Okay, we can't able to see the electrons. So but how we can able to get that this electron is moving or not? Okay, से हम decide करते हैं. We are taking this light energy and convert them into electricity. Okay, so ultimately we are measuring the light only in order to find the position of the electron. So हम जो measure करते हैं वो light ही measure करते हैं. So that's why it was very difficult to measure the position of the electron. तो इसलिए इस वजह से क्या है, इलेक्ट्रॉन का पोजीशन हम मेजर नहीं कर पाते. An intermediate frequency photon would only give mediocre readings for both. The equation above are used for solving for uncertainty of each variable proportional to the other and the constant h upon 4 pi. So this is the equation of the Heisenberg uncertainty principle. So in the exam you will ask find out the Heisenberg uncertainty principle. एग्जाम में आ सकता है. What is now we will take some basic that what is a Planck's constant क्या होता है, then what is frequency, because some of the students are unable to understand what I am speaking. So they must know what is frequency, they must know what is wavelength. So I am just quickly revising this. This is not part of your syllabus, but I am just going through this. These are the basic terms that we are using in this chapter. Okay. So what is Planck's constant? Planck constant क्या होता है? Planck constant is equal to what? 6.626 into 10 raised to the power minus 34 joule second. Okay. So which is a proportionality between frequency and energy. Okay. So this is the energy. Energy is equal to h mu. H nu. You know this relation E is equal to h nu. So h is what? E divided by nu. E divided by nu is equal to h. So it is the proportionality between frequency and energy. Okay. So Planck's constant क्या होता है? It is the proportionality between the frequency and energy. Okay. So this is the Planck's constant h multiplied by this h multiplied by with the frequency. So frequency is nothing but number of waves. Frequency क्या होती है? What is this frequency? Number of waves passing per unit second. So these are the waves which are moving per unit time. Okay, within 1 second, how many these waves are repeated? It's called as the frequency. तो उसे को प्लैंक्स कांस्टेंट बोला है. सेकंड जो टर्म हम यूज कर रहे हैं बार बार, दैट इज फ्रीक्वेंसी. फ्रीक्वेंसी क्या होती है? It is the number of occurrences or repeating of the event per unit time. So these are the number of events that are occur per unit time. उसे क्या बोलते हैं? Frequency बोलते हैं. Okay. So this is not part of your syllabus, but I am taking these basic terms. The frequency is the number of occurrence or repeating of the event per unit time. Frequency is measured in hertz. So you know the unit of this one. Frequency is equal to 1 event per second. Okay. The period is the duration of the time of one cycle is a repeating event. So the period is the reciprocal of the frequency. So frequency is equal to 1 upon t. You can write, we are writing down this like this also. Frequency f is equal to 1 upon t. But here we are using frequency as a nu. Okay. यहाँ पे f है. We are using it, उसका symbol यहाँ पे हमने nu करके, h nu is the frequency here. Okay. You just remember this one. So this is the frequency that is increasing here. Here number of this repetition or vibration is more here. Here it is less. Now another term that we are using, that is angular frequency. Angular frequency क्या होती है? We are using this term here also number of times. So what is angular frequency? Angular frequency omega is also known as the radial or circular frequency. Okay. Circular frequency. So this is the circle we have, and omega is the frequency, number of cycles this with which the wave is moving. So this is the wave we have, and this is the one cycle, which is equal to 2 pi. This is pi, that is 180 degree, and this is again 180 degree. It means 2 pi. Okay. So this is called as the omega. उसको क्या बोलते हैं हम? Number of cycles. Or omega is also represented as rate of change of. So this is the angle change with time. Okay. Changing angle with the time. उसे हम frequency बोलते हैं. समझ में आ रहा है सबको? हेलो?
Yes, sir.
So this is
Yes,
no,
sir.
nobody is taking, but I am taking because this is a basic. Some of the students can't able to understand what I am speaking, so I am taking this one. So angular frequency omega is also known as radial or circular frequency. Measures angular displacement per unit time. Okay. So this is the angular displacement per unit time, d theta upon dt. उसे क्या बोलते हैं? Angular frequency बोलते हैं. Measure of angular displacement per unit time. So its units are therefore degrees. उसका unit क्या है? Degree है और radians. Radians per second. Angular frequency in radians is larger than angular frequency in hertz. So this omega is always greater than f. Okay. Omega is always greater than f. Angular frequency in radians is larger than regular frequency in hertz by a factor of 2 pi. So what is the relation between frequency and angular frequency is this one. So omega is equal to 2 pi into f. So you should remember this one. But what is f? F is equal to 1 upon t. We know that f is equal to 1 upon t. So my equation for this angular frequency is 2 pi upon t. So this is the relation between the angular frequency and frequency. So I am writing the angular frequency as 2 pi upon t. Okay. So this is the relation that we got. Omega is equal to 2 pi f, or omega is equal to 2 pi upon t. where omega omega is the angular frequency measured in radians per second. So this is the angular frequency, or this 2 pi we have radian frequency. Angular frequency measured in radians, T is in period, F is the ordinary frequency we have. Now another term we are using wavelength. Okay. What is wavelength? Wavelength क्या होती है? So distance between the crest of the one wave to the crest of the another wave, or trough of the one wave to the trough of the another. उसे क्या बोलते हैं? Wavelength बोलते हैं. Okay. So wavelength is the distance between corresponding points of two consecutive wave. Okay. Two consecutive wave. This is one wave and this is another wave. So I have two wave. The distance between two wave is called as the wavelength. Wavelength is denoted by a Greek letter, that is lambda. So lambda is the wavelength we have. So it is equal to the speed v of the wave train in the medium divided by its frequency. So wavelength क्या होती है? What is the speed with which that is moving? V divided by frequency, number of occurrences. तो उसे क्या बोलते हैं? Wavelength बोलते हैं. So mathematical form of the equation for this wavelength is lambda is equal to V upon F. Another important term we are using again and again, that is momentum. Momentum क्या होती है? What is momentum? Momentum in physics is referred to the quantity of the motion that an object has. Okay. So this is the object. You can say any object, or you can say your mass multiplied by the velocity with which it is moving. तो उसे क्या बोलते हैं? हम momentum बोलते हैं. So this is the momentum of the vehicle with which it is moving. तो momentum क्या है? Mass of the vehicle multiplied by velocity with which it is moving. Okay. So instead of this vehicle, we are considering the electron and proton. Okay, mass of the electron, proton, and the velocity with which it is moving. Okay. Any object is in motion, then it has its momentum. Momentum can be defined as mass in motion. Momentum means what? Mass in motion. So all objects have mass. So if an object is moving, then its momentum is also change. Okay. So it has its mass in motion. So momentum is the product of mass of the particle and its velocity. So this is the concept of wave function. I will take this tomorrow. Tomorrow I will take this one. How much is the time? We have 10 minutes only. Okay. So this was the Heisenberg uncertainty principle of the electron diffraction. So this is small article that is on the basis of Heisenberg uncertainty principle. So earlier we had studied the diffraction of the light. So this is a small experiment in which we have taken the electron beam. So this is the electron beam that is moving here. So instead of light, earlier we had seen that light is get diffracted when it is incident on the slit. Okay. If any object comes on the path of the light, that what happens? Diffraction occurs. So at the center we are getting the maximum light and we are getting the minimum or diffracted light here on the screen on both the sides. ये हमने स्टडी किया है. ओके. रिफ्रैक्शन ग्रेटिंग एक्सपेरिमेंट में भी हमने ये स्टडी किया है. सो इन दिस एक्सपेरिमेंट हाइजेनबर्ग अनसर्टेनिटी principle by single slit electron diffraction. So here I allow the electron to pass through this slit. What happens? Electron beam is get diffracted here and we get the intensity of the ear. Let us consider a parallel beam of electron is incident on the narrow slit as shown in figure. Okay, यहाँ पे incident हो रहा है. The diffraction pattern is formed by the electron which pass through the slit. So this electron is diffracted by the angle theta. So theta is the angle of diffraction, and electron beams reach out here. So here we are get the another intensity of the beam of electron here. This is the first minima and this is the maxima, secondary maxima we got here. So diffraction pattern is formed by the electron which pass through the slit. But from the position of the slit, a particular electron passes is unknown. So by which position this electron will get diffracted, it is not possible for us to decide. So that is nothing but the uncertainty. Okay. But from which position of the slit a particular electron passes is unknown. Okay, this is unknown. So this is nothing but the uncertainty on its position. Hence, uncertainty in the position of the electron in the y direction is equal to width of the slit delta y. So delta y is the width of the slit. So that is the uncertainty on its position. Okay, from which position this electron is get diffracted. That is the uncertainty in this experiment we have. So delta y is the uncertainty in since the electron is diffracted towards the y direction. This is the y direction. This is the x direction. So we have taken this as a y direction as delta y. Okay. So delta y is the width of the slit. Intensity is concentrated in the central maxima. So we got maximum intensity at the center. Center में क्या है हमें maximum intensity of the electron beam is reach here. यहाँ पे हमें maximum intensity मिलती है. So that's why we got this curve. इसलिए हमने वहाँ पे maximum curve दिखाया है. Okay. So we are using curve for the mathematical terms. ये mathematics में हम curve के तो we understand in terms of curve. Okay, mathematics में हमें लिखना है तो हमें curve के language में लिखना पड़ता है. But you can see the light in the form of intensity. So on the screen we are getting in the form of intensity. Okay.
Yes, sir.
Yeah. Okay. So electron which passes through the slit hits the screen between A and B. So electrons are hitting here on the screen A and B. A and B point पे वो hit कर रहे हैं. So electron which passes through the slit hit the screen on A and B for the first minimum intensity form at an angle theta. So this is the theta with which we got the intensity of the electron. So the equation for that delta y sin theta is equal to 1 lambda. Okay. So this is the first minimum intensity in the mathematical form. वो में कैसे लिखते हैं delta y sin theta is equal to 1 lambda. Okay. So delta y is equal to lambda upon sin theta. Okay. So delta y is equal to take this sin theta here. Then it comes to the denominator. So the equation for the slit width is equal to delta y is equal to lambda upon sin theta. Lambda is the wavelength of the electron beam. Okay. So after diffraction, wavelength remains same. So when this electron is get diffracted, wavelength of the electron is the same one. Hence momentum also same. Since wavelength is, what is the relation between momentum and wavelength? Lambda is equal to h upon mv. Okay, this is the relation. Mv nothing but the p, momentum, lambda upon p. Lambda is equal to h upon p. We know this. Okay, so agar wavelength will change, then what will, you can say momentum will also change. Okay, so the after diffraction wavelength remains same, so you can say that momentum also same. Okay, so uncertainty in the momentum in the y direction is the momentum of the electron is equal to p is equal to h upon lambda. So momentum क्या है? P is equal to h upon lambda. So I had taken this p here and lambda here. So I had just exchange. So this is the equation of the momentum. Momentum is equal to h upon lambda. This equation I got here. So momentum of the electron is equal to p upon h upon p is equal to h upon lambda. So delta p is the change in momentum. Delta p क्या है? Change है. Small change in momentum is equal to h upon lambda into sin theta. H upon lambda into sin theta minus h upon lambda into sin theta. Then since both are minus minus, it becomes plus. So this final equation I got, that is 2h upon lambda into sin theta. So this minus minus become plus, so this become 2 times. So 2 times h upon lambda into sin theta. I got this equation number 2 here. Okay, यहाँ पर मुझे equation number 2 मिल गया. So from equation number 1 and 2, what you can say? What is equation number 1? We have equation number 1 as, where is that one? This is equation number 1. We have delta y is equal to lambda upon sin theta, and delta py is equal to 2h upon lambda into sin theta. So both from equation 1 and 2, you can say that delta y into delta py is equal to 2h into 2h. Since this lambda will get cancelled out if you multiply this with this delta y. Delta y is uncertainty on its position of the electron beam, and this is uncertainty in terms of momentum. So the final equation I got is equal to 2h. Okay, so you can say that delta y dot delta p is equal to or more than that of h. Okay, so you can say this, that since this is the delta y minus delta py is equal to 2h, so you can say that delta y dot delta py is greater than equal to h. So which is called as the Heisenberg uncertainty principle. Uncertainty, delta y क्या है? Uncertainty in its position. इलेक्ट्रॉन कहाँ पे मिलेगा आपको, you can't say. So delta y is the uncertainty with which position of the electron through which electron is get diffracted. Okay, कौन से position से, कौन से position of the slit with which electron is get diffracted. And p delta py क्या है? Momentum है. So this was proved by this experiment. So in the exam you will ask, explain the Heisenberg uncertainty principle by a single slit electron diffraction. तो आपको यहाँ तक प्रूव करना पड़ेगा. If your exam will be offline exam, okay, offline होगी तो आपको यहाँ तक प्रूव करना पड़ेगा. समझ में आ गया सबको? Now I want to